for our range, we would say 3x equals 3. We divide both sides by 3, so we would say x is equal to 1. So I'm sorry I started recording a little bit late, so I'm going to review just a second. So here we go, guys. Up here we were given the domain, but we were asked what is the range. So if we were given the x values, we just had to plug in our x values to the equation, to the function, and we got our range values. All right. On the second one, we were given the range. We were given our y values, and we're being asked to find the x values. So we've already done it for if we were given a 0 and if we were given a 3. Now we're going to set our function 3x is now going to be equal to 6. So what do I do to solve for my x, y'all? Again, just divide by the 3, and my x is equal to 2. Do you guys feel good about that? We do this one last time, but this time with 9. So 3x is equal to 9. Once again, to solve for the x, we divide by 3. So my x is equal to 3, because 9 divided by 3. So the domain in this case would be equal to, 0, 1, 2, 3. So that would be our domain. Up here, we were given the range. We had to find the range. Here, we had to find the domain. Do y'all feel good about that? Just depends on what they're giving us. So let's look at number 3. The domain of h of x is equal to 4x minus 12 is 1/4, 1, 3, 5. What is the range? So guys, are we given our x's or are we given our y's? Anybody? What are we given? We're given the x values because we're given the domain. They want us to find our y values. They want us to find the range. I personally think this is a little bit easier because you just have to plug in the values to get what you want. Okay? So in this case, we would say, okay, so h of x is equal to 4x plus 12. So I'm going to replace that x with these numbers here. So that becomes 4 times 1/4 plus 12. And so what does that equal? 4 times, that's going to be 11. Oh, it's not plus 12. What is it? What's my equation, y'all? It's minus 12. I was wrong. Please forgive me. Okay? So what is 1 minus 12? Well, that's going to be negative 11. Then we're going to do it again. We're going to say, okay, 4 times what? Now we plug in a 1 right there. I'll do that in my blue. Minus 12. So 4 minus 1. I should have done that one in blue. So 4 times 1 is 4. 4 minus 12 is just negative 8. Y'all feel good about that? Then we do it again. But this time we plug in our next domain value, which in this case is 3. So 4 times 3 is 12. Minus 12 is 0. And last but certainly not least, we do it with a 5. 4 times 5 minus 12. Well, what's 4 times 5, y'all? 20. 20 minus 12 is going to be equal to 8. So in this case, my range is equal to negative 11, negative 8, 0, and 8. Make sure you list it from the least to the greatest. Alright, how are you guys feeling with that? Is that okay? Not too bad? Alright, so I want to show y'all something that's kind of cool on your calculator. Okay, I showed you guys back here, if you want to plug them each in, you can do it with different values. I also want to show you guys something neat. So if you don't have a calculator, now would be a nice time to go grab one from the front. If you do have one, please turn it on. And what I want to show you guys is this little y equals button, okay? If you guys hit y equals, it takes you to a list of equations, okay? Now, if you have one of these TA84 plus CEs, it like gives you different colors, and that's kind of nice. If you just have a regular one, it's just going to say y1 equals, y2 equals. So guys, check this out. If I went up and typed in my equation from number 1, and I typed in negative 1.5x plus 4. Okay? I'm not going to actually graph it, but what I want to see is I want to see my table values. So how you get to your table, do you guys see how it's written in this little blue word right up here? How you get anything that's written in blue is you have to push second first. It's kind of like the shift button on a computer, right? So do second graph or second table, and it takes you to a table. And guys, what I want to show y'all from this first problem, how do you get x? Oh, good question. Okay, so the x button, if you go to y equals, do you see it's right next to the alpha? It says x, t, theta, n. When you type that in, it gives you an x. Good question. Okay, so once you type in negative 1.5x plus 4, because that's the equation that we had, I want you to hit second graph or second table. And guys, look at the values that it gives you. When I plug in a 1, what does it give you? 2.5. When I plug in a 2, what does it give you? A 1. If you plug in a 3, it gives you negative 0.5. And if you plug in a 4, it gives you negative 2. So guys, the table will also give you your values. Now this is super great if everything in your domain is whole numbers, right? But look down here, if we did the same thing on number 3, and we did it, and we went back to our y equals and cleared it out, and wrote 4x minus 12, and hit second table, well sure, it gives me the values for 1, 3, and 5, but does it give you the x value of 1/4? No. So this is nice, but it has its limitations. Does that make sense? So you still need to know how to plug it into, like hand write it, paper and pencil. But I also wanted to show you that you can also find it with the table of values in your calculator, which is kind of cool, right? So it gives you, for 1, it gave us negative 8. For 3, it gave us 0. And for 5, it gave us 8. But you still would have had to go in and do it for 1/4. Does that make sense, y'all? But it's a good starting point, and it's a good lesson. For number 2, if we typed in the y equals 3x, and you went to your table, remember, they're not giving you the y value, or the x values, they're giving you the y values. So you would have had to find where it was 0, 3, 6, 9. Okay? And it just so happened that it was 0, 1, 2, 3, which is kind of nice. Now guys, in your table, you can always scroll up and see negative values. You can scroll down and see positive values. Sometimes kids like scroll forever and ever and ever, and then they're like on 100 values. If you ever want to reset your table, you do this second window, and you can be like, okay, I want my table to start at 0. And you go back, and it brings you back to 0. So sometimes some kids mess with it, and it gets up to like super high numbers. Okay? But that's kind of a cool trick. Do y'all feel good about that? Okay. So now, what I want to talk to you guys about is reasonable domain and range, okay? So when we're dealing with word problems, we want to use a reasonable domain and range. Since only certain values make sense, right? If we're going to deal with time, would it make sense to have a negative value? We cannot go back in time yet, all right? So when we can, I guess that will be a part of our math. But for now, we can only move forward in time, all right? And so that cannot be a negative value. But even though there are limitations in a real world context, each type of graph still has, and I don't know why there's only one blank, a domain and a range. Okay? So each value still has a domain and range. So we are going to talk about this with this example right here with our boy Charlie. So Charlie received a gift card for $20 worth of media downloads. The cost of each download is $2.50. So I'm going to go here. So what are our two variables in this case? What do y'all think? What do we think our variables are going to be? You don't have to say if it's X or Y yet, but I just like, what are the two things that we're dealing with? We're dealing with money. Do y'all feel good about that? One of our variables is how much is on the card. Okay. And then the other one is the number of downloads. So guys, we have a number of downloads. It also kind of tells you in the lovely little table. And we have the balance on the card. So that's going to be like our money. So guys, does the balance on the card depend on the number of downloads you have? Or does the number of downloads depend on the balance of the card? Ooh, I guess you could argue it either way. But your balance, which one goes first though? Like, do you download music first and then it affects your card? So the independent variable is the number of downloads you have. So Sophia, usually your money is going to be your dependent variable. Because like your total cost of something usually depends on how much you buy, right? There are some circumstances where you might start and be like, okay, I only have $20, so I got to keep it under $20. But that's still your dependent variable, okay? So we have the balance of our card is going to be our dependent or our Y variable. And our number of downloads is going to be our independent or our X variable. So if we wanted to write a function rule, I'm going to do this with, are you guys okay with f of x being my y? Are y'all good with that? So f of x is equal to what? Well, how much money do we start with? $20. Okay, so I'm going to say $20. And then, we're going to be subtracting. Why do you guys say subtracting? That is correct. You're taking away money from the card. Yeah, every time you download something. And how much do we take away per download? So it's going to be $2.50 per download. Is this situation going to be discrete or continuous? What do y'all think? Okay, discrete numbers have to be counted in whole numbers. Continuous can be broken into halves. So do you think which one is it going to be? Can you download half a song? So if it's got to be whole numbers, this one would be discrete because you can't buy half a song. You can't be like, I just want the chorus. I just want to spend $1 for the chorus. Okay? Also, you'd probably be really sick of the chorus, all right, if that's all you listen to over and over again. So you can't buy half a song. Okay, so now we're going to create a table. Okay, oops, sorry about that. Remember, my X values are my number of downloads. My Y values is how much it costs. So let's think about this, y'all. My number of downloads. If I have 0 downloads, how much is on my gift card? How much? $20. If I do 1 download, how much is going to be on my gift card? How'd you guys get that? You subtracted $2.50. Excellent. So I'm going to do I guess I should do $20 like that. I don't know. Whatever. You can just do 20 or you can do 20.00. If I do 2 songs, how much will be left? $15. Okay? If I do 3 songs, we would get down to what? $12.50. Then we'd get all the way down to 10, $7.50, $5, $2.50, $0. Do I keep going? Is that reasonable? Can I have a negative amount left on a gift card? No, they just stop selling your songs, right? So, or they start charging your credit card, right? But guys, so these right here, we would be done. So are these reasonable? Is this a part of our reasonable domain or range? No. So this shows us that it ends. Okay? Now let's say you're not a mental math person. That's okay. You could have done this a few different ways. You could have sat here and done 250 times 1. Right? 20 minus 250 times 2. You could have sit there and done it like that. You also could have typed your equation into your y equals and looked at your table. And you could have seen it. Now guys, when I type this in as a line, does it just keep going? Do the table values keep going? Yeah, the calculator's not smart enough to know that we should stop at 0 because it doesn't know that this is about a specific situation, right? So the calculator keeps going. So you have to, so guys, that's why the calculator is smart, but it's also not super smart. So you still have to know enough to be able to determine which values, where we stop. Does that make sense? You still have to use your brain a little bit. Okay? So now we're going to go here. And I'm actually, before I make my graph, I want to talk about a reasonable domain and range. So guys, remember, the reasonable domain is going to be what? It's going to be all my x values. And because this is discrete, I have to list them all out. Okay? Because it is not any number of songs from 0 to 8. It's whole numbers. It's not 0.5, it's not 1.75 or 5.667, right? It is whole numbers. So remember, your domain is your x values. So that's why I like things in the different colors, because it kind of shows it. But as long as you know that your x values are your domain. So if that's a reasonable domain, what's my reasonable range? What would be a reasonable range, y'all? It would be the remaining balance. And guys, remember, we always list from least to greatest. So in this case, we would start at 0. And then I'm only going to, just to save room, I'm going to say 2.5, 5, 7.5, 10, 12.5, 15, 17.5, and 20. So that would have been a reasonable domain and a reasonable range. Now once we have all these values, once we have our table, domain, range, we can make our lovely little graph. So guys, remember, my x values in this case were my number of downloads. Oops, forgot the D there. And then this is the balance. Your y values was the balance remaining on the card. So it already listed our 1 through 10 here. So I'm going to go ahead, I'm just going to do these by 2s. 4, because we got to get all the way up to 20. 14, 16, 18, 20. Do y'all feel good about that? So then I'm going to plot each little point here. So I'm going to say 0, 20, 1, 17.5, 2, 15, 3, 12.5. And it's okay if it's not perfect, but we want to try to be as accurate as possible. And you guys notice, is this decreasing at a consistent rate? Yeah, because each song is the exact same amount of money, right? So here is my question for y'all. Do I connect all these dots together? No, why not? You do not connect it because it is discrete. So even though it makes this nice pretty line, you don't connect. Okay? Because you can't have half a song. Very good. Okay? So if we were talking about continuous function, then we would connect those lines. But discrete functions, we just plot the points. Do y'all feel good about that? Excellent. Okay, so we're gonna move a little bit quicker on the back side of this page. We're gonna do I'm gonna do number 5 with y'all. Okay, on the back side here, and then we're just gonna talk through 6 and 7. Okay, so let's look at number 5. You rent a paddleboard from 11 a.m. to 2 p.m. and it costs $8 per half hour. Interesting. For the paddleboard, plus $5 to rent for the day. So what's the maximum number of hours I can go? Only 3 hours, right? And how much is it per hour? Yeah, if it's 8 per half hour, it's going to be 16 per hour. Do you guys feel good about that? Okay, and if we're asking for the greatest range, we're asking for our y values, aren't we? So guys, it's hours versus cost, okay? So in this case, my x is going to be the hours, and my y is going to be the cost. Because like we suggested before, the cost is usually your range. It's usually your output. Also, if you have time is always going to be your independent variable. It's always going to be your x. Minutes, hours, days, weeks, it's always going to be your x value. Because we can't control time. Time is independent. It moves whether we want it to or not. All right? As every mother of young children would say. It moves whether we want it to or not. All right? So, as we see here, we are going to, now we need to write a function. All right? So, we can write this as f of x equals or y equals. So if I write y equals, my cost is equal to what? How much per hour? $16 per hour, which is my x. And then do I have to add anything to that? What? Because you have to have a life vest. Alright? So we just add 5. Now that isn't controlled, the $5 isn't controlled by the number of hours, so we don't multiply it by the x. We just add it on at the end. Okay? And so the question said, what is the greatest range? So what's the greatest range value? What are we going to say? What would our x value be for the greatest range? What's the most amount of hours they can have it, y'all? 3. So we would say, okay, 16. Instead of x, what would we put in? 3. So 16 times 3 is what? 48. Plus 5 is equal to... that is not correct. I almost wrote a 4. That would be equal to 53. Do y'all feel good about that? Oh, man. Alright. Oh, my thing might have died. That's okay. So I was trying to do the little the dollar sign, actually. Because it's 53 bucks, right? So, the way that I would say this is I would say, okay, at, 3 hours, it costs $53 to rent a paddleboard. Okay, so at 3 hours, it costs 53 bucks to rent a paddleboard. Do y'all feel good about that? So at the very most, the greatest range that they would spend would be $53. All right. So now for 6 and 7, what we are going to do, y'all, is we are going to look at this and we are going to see, oh, I think I used up all my write-out. Wow. We are going to see, I'm going to show you these, but guys, I don't want you to be like rushing to write all these down, okay? Because this is on my Canvas if you want to work to write it down, but I really want you guys to listen as we're doing this as well, okay? So, let's take a look at this. If you have 3 quarts of paint to trim your house, paint the trim, and if we know that a quart of paint covers 100 square feet, or 100 feet square, the function A of Q, which is I guess the area, is equal to 100 times Q, represents the area of A of Q in square feet that Q quarts of paint cover. So we can create a little table here, and for each quart we cover how much square feet? 300. Okay? And guys, in this particular situation, so every time we had 0, then 100, 200, 300. In this situation, it would be continuous. Because, do I have to only paint in quarts? No. It's not like you buy a gallon of paint and you're like, well, I guess I got to paint it again. I got to finish this wall because I have to use the whole gallon, right? I got to paint 10 coats because I got to finish it. No. You can stop at half a quart, third quart. You don't need to use the whole thing. In fact, it's nice to have some extra just in case there's any mistakes later, right? So this is going to be continuous. So the area, yes, I plotted those points, but I connected those lines. Does that make sense? Did I have to have whole values for my quarts over here? I picked whole values because those are easy numbers, but I could have easily picked 0.75 quarts as one of my X values and gotten 75 square feet. Okay? So we could have easily not done whole values over here. But I graphed these points, and this is generally what it would look like. For 1 quart, it was 100 square feet. For 2, it was 200. For 3, it was 300. Now, one thing I want you to notice is I did stop it, right? Because it can't go past 300 square feet because we only have 3 quarts. If we had more quarts, we would get more. Then we look at this. Guys, our reasonable domain, you go from the smallest to the X. I mean, the smallest to the biggest. Well, guys, my X values were my quarts. So I went from 0 to 3. Now, could it be equal to 0 quarts? Absolutely. Could it be equal to 3 quarts? Absolutely. So that's why I did the less than or equal to on both of those. Your range goes from the smallest square feet to the largest square feet. So we went from 0 square feet all the way up to 300 square feet. And technically it could be equal to 0 square feet, okay? If my child was painting, he might paint 0 square feet, all right? He might just end up playing with his Legos instead of actually doing what I've asked him to do, okay? I'm sure that's never happened, right? And then if they used every drop of paint, they could paint up to 300 square feet. All right? So this was an example of a continuous function and kind of what it looks like. Now over here, number 7 is another great example of a continuous function. Okay? Because they show us, first of all, that's really good gas mileage. Right? 32 miles for each gallon. And that is represented by this function, d of x equals 32x. And it represents the distance traveled that the car can travel with x gallons. Guys, it gives you the x and the y. Sometimes it gives it to you. So the x is our gallons, the y is our distance. And this was important. It holds a maximum of 17 gallons. So guys, we can't go above 17 gallons realistically. So we have to think about the reasonableness here. So this situation again is discrete. Because you don't have to just spend 1 gallon of gas exactly. You can spend half a gallon, 0.75, 4.5 gallons. You can do it in half numbers, right? It can be counted in half, decimals and fractions. So in this case, my reasonable domain was the smallest gallons to the most gallons. So we went from 0 to 17. My reasonable range was the smallest distance to the largest distance. So if we spend 0 gallons, we go 0 distance. If we spend all 17 gallons, we got to do 32 times 17, so that's 544 miles. So that's 0 to 544. And this again would be a continuous function. So I used my domain and my range to build my graph. Could I put other points in there? Sure. But do I need other points? You just need 2 points to make a line. Alright? How do you guys feel about this reasonable domain range? Does that feel a little bit better now than we did last time? Okay, excellent. So what I want to